H2O. I think this is the best known molecule in the world that we know of. The mere fact that water makes up more than 70% of our body composition. The fact that it cushions our joints, it cushions our organs, it helps to burn food, turn it into energy in our body, take the nutrients to our cells. The fact that animals have to have water, the plants need it, the oceans wouldn't exist without water, I think is living proof that the driving force behind nature is water. So water is everywhere, and every living organism needs water somehow to survive. As such, I think it's fair to say that water is life. Life is water. Without water, we wouldn't exist. Water can be life, but water can also be death and destruction. Too little of it, then humans die, starve, they can't grow crops. Too much of it, again, we have a problem. It caused devastation, it changed geographies, tsunamis, floods. They change the social fabric of our civilization. And the way we use water, or for a better word, I think, abuse water, the way we mistreat it, the way we mismanage it, is also causing a lot of problems. In Asia, we're all familiar with the frequent floods and too much rain at times, and we have probably all experienced some type of flood in our lives at some point. And all of that, the devastation that it caused over and over again every year, I think is all too familiar to us. So life, death, destruction, misery, and I think water can cause both depending on how we use it. But we also use water to create energy. Almost all power plants that we know of, whether it's a hydroelectric power plant that runs purely on water, or whether it's a nuclear power plant or a fossil-based coal or gas power plant, uses water in its process in some shape, way, or form. You can argue that solar energy or wind farms, the renewable energy sources that we are trying to push more and more these days, they don't use water in the process. Well, maybe I agree partially, but I'll come to that later on. So we use water extensively to generate energy, but we also use a lot of energy pushing water around for our own needs. So the most common method of getting water from its source to your homes or to where it's needed is pumps. And pumps are driven by motors, and usually by electric motors. And did you know that in the world today, 10% of the electrical production, electrical energy that we manufacture, we produce, is used by pumps to move water, to push water around, to get water to where it's needed. 10%. Big scale. And then pretty soon we'll start seeing hydrogen fuel cells commercially available in our lives. And already hydrogen fuel cell car is coming out from several manufacturers. And those cells, in principle, very simply put, use water as the main ingredient and then put out water as the final byproduct. So energy straight out of water. So the use of water in energy, in creating power, is really gaining momentum and getting big. Not only we need water for our own use, but we also need it for energy, for creating our power, for sustaining our civilization. So if water is that important, and I think we all agree that water is critical to life, to civilization, why does the world not have a sustainable water policy, water management policy? Yes, in some countries, in some institutions, there's a lot of work going towards it, and a lot of governments are appointing and creating new ministries to look after water management and water resources. But it is still in its infancy, and recognizing the fact when the UN put out its 2030 Global Sustainable Development Goals, water was firmly on the agenda. Out of the 17 Sustainable Development Goals for 2030, which the whole world, all governments are supposed to be focusing on to make lives and our world a better place, 2 are related to water. The development goal number 6, which is clean water and sanitization, so ensuring that every human being has access to clean water and sanitization. And number 14, which is life in water, so oceans and seas as we know it. But let's look at number 6, which is much closer to home for our basic needs. Clean water and sanitization for all. Do we have enough water in the world to do that today? Our big blue planet, it's there, you can see it, it's covered with water. 71% of the planet is covered in water. And the water that covers the world is mainly oceans and seas. So saline, a lot of salt in it, and therefore not readily consumable, is not fit for consumption by the living organisms in its existing format. So 97% is in the seas. Only 3% is available as fresh water for us, for animals, for plants to consume. And out of those 3%, which is mostly and largely locked in ice caps in the glaciers, 69% is out there, frozen solid, and needs to be thawed before we can use it. 69% is trapped in ice. Then another 30% is trapped under the ground as groundwater, ground lakes, ground streams, and it needs to be brought out to the surface before we can use it. So when you do the addition, only 1% of the fresh water that's available in the world is in surface water, so lakes, rivers, and swamps. So you do the math, 1% of 3%. So 0.03% of the water that we have in the world is available, readily available for human consumption. And that would actually be pretty okay to sustain the world and the world population today if we could distribute it and manage it in a fair and sustainable way. But unfortunately, not everybody is as fortunate as we are. Not everybody is as lucky as we are. In most of Africa and also certainly in Central Asia, the less developed communities, the rural areas, there is a real problem with access to water, access to clean water. And many people in their daily lives spend a lot of time looking for water or fetching water, bringing water back home, especially women and kids. They are the main water makers, if I may call them so, at home. And women, children, they spend on average in those countries, in those communities, 6 hours a day walking 6 kilometers looking for water, finding water, bringing water back home. 6 hours, 125 million hours a day is spent by women and children to fetch water, to find water. And as I said, children are involved in that. But of course, the water that they find is not always necessarily clean water, good for their health. And a lot of the time, they have to use contaminated water or dirty water. And in those dirty waters, all sorts of diseases and problems lurk. From malaria to cholera to typhoid, or if it's an industrially polluted piece of well, then even touching that water could give you burns and rashes. So, and even death maybe According to the studies, between 900 and 4,000 to 5,000 kids die every day from preventable waterborne diseases. That's a huge, staggering, and sad number. And I'm not going to bore you with more statistics, but just to take one from what you see on the screen, every 90 seconds, that's the low end of the estimate. The high end of the estimate says every 15 seconds. Every 90 seconds, a child dies from waterborne diseases. Considering that I've been up here on stage for about 12 minutes now, that is 8 kids that has died since I started talking here. When we talk about these figures, we all know about them, but maybe we don't really get the real thing. If I had 6 kids standing next to me here, sorry, 8 kids standing next to me here, every 1.5 minutes, every 90 seconds, one of them would be falling down. And I think that would be a grim thing to watch for all of us. So think about that when we're reading these statistics. But also to say a few positive things about water and how water can create change in the community and help lives. Every $1 that we invest in water creates, again, according to different studies, between $4 and $8 in repeat economic activity. So you can imagine, it's not just helping those people, those societies, or animals, or plants to have a better life, but also we create economies. We are helping the kids to be more healthy. And when they don't have to go and look for water, they can go to school. So it also helps to stimulate the economic development of the communities. So on average, a person needs between 50 and 100 liters of water to get by during his or her day. Some countries a little less, some countries a little more, but on average in the world, 50 to 100 liters that we consume for ourselves. We drink it, we wash in it, we brush our tooth, we cook in it. So, and that amount is only the visible part of the iceberg. Only 10% of the use of water in the world goes into domestic and personal use. 90% goes into agriculture and industry, into production. And depending on the development level of the country, of course, the figure changes. The more developed countries are more industrialized, so they use more water in industrial production, and the developing part of the world is using more water for agriculture. But on average, 70% is used on agriculture, 20% used in industry, and only 10% by people in our daily lives and what we need to consume to stay alive. But is that all? 10%? What about the remaining 90%? Don't we have a share in that? Everything we eat, from burgers to fish to cattle, or everything that we buy, from shoes to clothes to shirts, everything uses water in some shape or form in its production. When we grow crops, when we cut even metal, we always use water in that. So that's called invisible water, or the hidden water. So when we talk about invisible water, let me ask you a question. Have you ever heard of carbon footprint? Yes, I think we've all heard about carbon footprint, and it's a big thing on the world agenda. We are all trying to reduce emissions. We are trying to make sure that we pollute the air less, and there is carbon quotas for countries, companies, and there's even a stock exchange, a carbon trading scheme, where I can buy your carbon emissions because I'm emitting less. It's a big thing. Everybody knows about it. But what about water footprint? Did you hear about water footprint? Water footprint is almost as important and as critical as carbon footprint for the world to really take notice and do something about. And the water footprint, as I said, everything uses some water. So everything that we use for our own consumption, everything we eat, everything we buy That adds up to our total water consumption. And that's our water footprint, our business's water footprint, our government's water footprint. And you see some numbers there on the screen. And all this talk got me thirsty, sorry. Just while I have this in my hand, question for you. This is less than a liter, but most water bottles, bottled water, is about a liter. Do you know the water footprint of a 1 liter water bottle? So this one uses 5 times the amount of water inside in its water footprint. So a 1 liter bottled water comes at the expense of 5 liters of water. Imagine, we don't think about that when we drink the water. We just consume 1 liter water and we usually throw away half of it, but there's actually 5 liters water that's gone into making that. So please think about that water footprint. And things are not actually going to get better. It's also going to get worse in the sense that by 2050, the world population is estimated to be around 9.1 billion. So another 2 billion people needing water to survive, as well as goods to live a comfortable life that requires water for its making. Not only the world population will grow, but world production is also expected to grow. Industrial water need is expected to go up by 400%, 2050 again. You can do the math. And the way we are using or abusing water, I think, is not sustainable at all with this data and with the water footprint that we have. Not only the water footprint, but also our way of life is putting an extreme pressure on the water's natural cycle. Because in nature, water is everywhere. Some of it evaporates and then falls down back on Earth in the form of rain, gets through the ground, filtered, and joins an underground stream and a main source of water. And there's a natural cycle that it follows. When we build our urban lifestyle, we build big cities, we cover the floors, and we disturb the whole natural cycle of water. So not only water cannot escape to the ground for it to be filtered naturally and passed back to the water reservoirs, we also collect it into sewage systems, and before we return it back to the nature or dump it back to the nature, we also pollute it. So it's a double whammy situation that we create with our urban lifestyles. Of course, there are technologies available already to address this issue, whether it's our lifestyle or our production processes. So technology is there. Technology is not an issue. Some of it might be a little more expensive today, but when it hits the mainstream, of course, it will come down in terms of the cost. And also compared to the cost that the world has to pay if you don't use those technologies, then cost becomes a non-issue anyway. But of course, the technology comes with its own challenges and its own footprint as well. Water footprint. Technology has a water footprint as well. Earlier on, we talked about solar and the wind power. And I said, well, maybe slightly, partially I agree with that. They need water also in the production of the turbines and in the production of the solar panels. So also those renewable power sources and power plants need water in some shape or form to make it happen. Water, as we saw, can be the source of misery, can be death and destruction if misused or mismanaged or is not treated well. It can also be the treasure that will help to improve lives and that will help the humankind ultimately. And the decision is really ours. The decision is really yours. So next time you brush your teeth or you take a shower or you drink water from a bottle versus from the tap, think again. And I think we can all do something about it. And it's our world, it's our life, it's our children's life. And we can all make a difference. So when you leave, please think, what will you do differently after this? Thank you.